Go really fast. We have plenty of time. So I'm just going to ask you guys a few things to go over a few things from yesterday. We're going to continue today, and I think tomorrow we'll just have an in-class assignment to really get you all understood with section 1. As I said, there's only 2 sections with this entire unit. All right. What does it mean if something is oxidized or if oxidation has occurred? David. All right, electron, either plural or singular, or lost. Remember, you can say lost, you can say donated, you can say taken. I don't care what verb you use, as long as you are conveying that they are no longer with that molecule or compound, it's fine. And what is reduction? Tim? Electron or electrons is or are gained. Why do they call it reduction if you're gaining something? Francis?
Because like your charge is going down.
It's called reduction because the gaining of electrons reduces the charge. Okay? So, if you have a compound such, or if you have a formula, or not a formula, an equation such as this, what is the cation in this reaction? Is it sodium or is it chlorine? Arshan? Sodium. Sodium is known as the cation. And chlorine would be the anion. Do the cations always gain electrons or do they always lose electrons? They always lose the electrons. And anions always gain those electrons. So generally, guys, the cation, the positively charged ion, will it be the one that gets oxidized or will it be the one that gets reduced? It gets oxidized. And the anion is the one that gets reduced. That's pretty much going to be the common theme here. Now, if something has been oxidized, that means that it lost an electron or it gave that electron up to the thing that was reduced. Just like we did the exchange yesterday through Jane and I took her pencil bag. That pencil bag represented an electron. If I took her electron, she got oxidized, but I'm the one that took it. So I was the oxidizing agent. It's kind of like acid and base, conjugate acid, conjugate base. If something is oxidized, it is the reducing agent. And if something is reduced, it is the oxidizing agent. So I just want to do a couple new equations before I get into what I have for you today. And then I think we're going to finish off section 1 today. So I just want to do a few examples, see if you guys can figure them out. Here we go. Let's see. We'll take a look at the periodic table here. All right. Can you tell me the oxidation numbers? What is the oxidation number of magnesium? I see a lot of you looking at the periodic table. Very good. Kevin? Positive 2. What is the oxidation number of phosphorus? Tim? Negative 3. Very good. So do positive 2 and negative 3 have a common multiple? 3 and 2, what do they both equal? 6. So you have to multiply positive 2 times 3 to get positive 6. You have to multiply negative 3 times 2 to get -6. So how many phosphoruses do we need? We need 2. How many magnesiums do we need? We need 3. Very good. And they cancel out. Now, how do I know that it's canceled out? Well, I've been saying this for years, and with you guys, I've been saying it all year. Do you see any charge symbol in that highlighted area? There is no charge symbol. So when you don't see one, the charge is not there. It is neutral, which means the positive aspect must cancel out the negative. So +6, -6 cancel each other out. Let's try another. Okay. What is the oxidation number of the iron? Let's see. How do you know?
Because we know oxygen is -2.
Good.
So in Fe2O3, oxygen has a -6 charge. So iron has to have a
Okay, let's break this down. Guys, what block on the periodic table would you find iron? S, P, D, or F? It's in the D block. And if you remember, the D block is composed of a lot of transition metals, which can actually have varying charges. But what Arshan said is accurate. If you look at iron just by itself, you don't look at what it's bonded to. If you just look at iron, you cannot tell if it's +1 or +2 or +3. You have to look at what it's bonded to. It's bonded to oxygen in this problem. You do know what the charge, or excuse me, in this case, the oxidation number of oxygen. What is the oxidation number of oxygen? -2. How many oxygens are there? We have a coefficient of 3 and a subscript of 2. So what is 3 times 2? So there's 6 oxygens. Actually, I didn't put that. There we go. That's better. We have -2 times 6. Is that right? Hold on. -2, -2. Yeah. There's 6 of them. So it's going to be -12. Some don't look right, though. And then iron is positive. It's actually 3, guys. I knew that didn't look right. There's 3 O2s. Hold on a sec. 3. No, that was right. I was right the first time. I was thinking of something else. So there are 6. -2 times 6, because 3 times 2 is 6. That's going to be -12. Now, with the irons, it's actually going to be 4 Fe, not 2. That's where I was messing up. It's +3 times 4. It's going to be +12. And they balance out. Sorry about that confusion. That should have been a coefficient of 4, not 2. Okay. Now, for the first time, and I think forever, I am going to ask you to open up your textbooks. So please open up your books to page 178. Okay. Let's have a quick review of electronegativity. Electronegativity is defined as an atom's ability to attract electrons. The more electronegative an atom is, the more able it is to attract electrons. We did electronegativity way back in the first semester, maybe the first quarter. So it's been a while. Do any of you recall what is the most electronegative element on the periodic table? Arshan?
Chlorine.
Fluorine is the most electronegative. I'd like you to take a look at page 178, 179. I think it's 179. What is the value of fluorine on that little figure that you guys have of the periodic table? We're going to say 4.0. Is there anything that rivals that? No. Take a look at the periodic table, and can you tell me what is the weakest or least electronegative element on the periodic table? It is named after a country. What? Francium. Shocker. The weak one is francium. Well, I'm bringing this up because what we did yesterday was ionic compounds. You can also have electronegativity when it comes to molecules. So for example, nitrogen gas and hydrogen gas yields ammonia. These are all molecules. I can tell that they are molecules because you have nonmetals bonded to nonmetals. Nitrogen bonded to nitrogen, hydrogen bonded to hydrogen, and then nitrogen bonded to hydrogen. But I want to know what is being oxidized and what is being reduced. That is the goal here. So I'm going to draw this arrow going here. I'm going to draw this arrow going there. Can you guys identify for me what would be oxidized and what would be reduced? Well, to figure that out, you need to ask yourself, which element is more electronegative? Is it the nitrogen or is it the hydrogen? What is the electronegativity value of nitrogen according to page 179? 3.04. What is the electronegativity value of hydrogen according to page 179? I heard 2.2 and 2.4. 2.2. So which element is more electronegative? Here's the hint. Whichever one is closest to fluorine wins. So according to the definition of electronegativity, the more electronegative you are, you're going to take electrons away. So who will be taking electrons from who? Will nitrogen take them from hydrogen, or will hydrogen take them from nitrogen? Nitrogen will take them from hydrogen. So is nitrogen being oxidized or reduced? Reduced, because it is the taker. And hydrogen is being oxidized. And the exchange is going to result in positive negative attraction, and that's going to bring them together. Let me try another one with you. Let's do water. Formation of water. Now, you don't necessarily need to look at page 178. All you have to ask yourself is which element is closest to nitrogen, or excuse me, fluorine. Is oxygen closer to fluorine, or is hydrogen closer to fluorine? So oxygen, is that being oxidized or reduced? Tell me why. I just finished on my AP Bio kids. I told them, in this AP Bio class, you can't just say 1 + 1 is 2 and then walk away. You have to say y equals 1, or y is 1 + 1 = 2. In this class, you can't just say oxygen was reduced. Why? How do you know? Because there are students in this room that are thinking, what? So how do you know, Derek?
Because you said the one with the higher electronegativity takes it away from the other one, takes an electron from the other one, and when you take an electron from one, it means you're oxidizing the other one, which means you're reducing.
The element that is more electronegative will take electrons from the element that is less electronegative. In this case, oxygen is more electronegative than hydrogen. How do we know? Because oxygen is closer to fluorine on the periodic table. Reduction means you are taking electrons. You are gaining electrons. If oxygen is more electronegative, the definition of electronegativity is taking electrons, oxygen is being reduced. Yes, Francis?
So cations and anions are only for like ion.
Correct.
So
Yes.
But in molecules, do they share the electron?
They eventually share them, but one of them, but Arshan, imagine this. Let's say that we're going to share lunch, but am I going to come to you or are you going to come to me? Whichever one is more electronegative is going to attract the one. Like when we have water, oxygen and hydrogen do share, but hydrogen goes towards it. It's like, dude, let's play today. Well, you're going to come to my house or I'm going to come to your house? You know, which one has more stuff? Someone's got to go somewhere. You can't meet in the middle. The weaker ones are drawn to the stronger ones.
And in diatomic molecules, since like they have the same electronegativity, is there like what happens?
It gets pretty tricky. It depends on which ones they are. You're typically not going to have ones in the D block, or not the D block, group 17, the halogens bond with each other. I believe if you had oxygen and chlorine or nitrogen and chlorine, things like that, the electronegativity values would be nonpolar. So you would have to depend on dipoles where all the electrons would be on one side temporarily. Remember we talked about that? And it forms a dispersion force. All right. So let me see if I can think of one more for you guys. Sulfur. Okay, here we go. Which is more electronegative, sulfur or chlorine? Which one is closer to fluorine? Double check to make sure. I'm pretty sure you're right. Just look at the two values. Okay, good. So which one is being oxidized? Sulfur is being oxidized. And chlorine is being reduced. Okay. So this whole strategy is to help you guys just identify what's being oxidized, what's being reduced. The last thing I want to go over is something I did yesterday. You need to identify if electrons are being added or if electrons are being taken. If something is a product in any given chemical reaction, for instance, I want you to look at this. I want you to look at AB. Is AB being added to this equation or is AB being produced from this equation? It's being produced. So is AB going in or is AB going out? It's going out. Okay, take a look at this problem. I want you to look at the 3 electrons. Are the 3 electrons reactants or products? Correct, they're products. Does that mean that the electrons are being gained or are the electrons being lost? Are they on their way in or are they on their way out? The electrons are on their way out. And as I told you, I don't care how you phrase it. They're on their way out, they're being lost, they're leaving, whatever. Point is, they're gone. What type of problem, what type of a process are electrons leaving? Oxidation or reduction? This is an oxidation reaction. You can tell because electrons are products. The electrons are on the way out. They're gone. See you. And then vice versa. The electrons here, are they reactants or are they products? They are reactants. They're on the left side of that arrow. Does this mean that they are entering the reaction or are they exiting the reaction? What's another way that you could describe, that you could say that they're entering? Oh, yeah, that's ultimately what I'm getting at. But like when new freshmen are going to start next year, they are being gained by Plant High School. We have new students being gained by the school. This is known as reduction. Whenever you see electrons as a reactant, that is an example of a reduction reaction, okay? So I'm gonna write out a big problem here and see if you can put it all together, and then we'll move on. When we're done with this problem. Okay. Now, your brain may still be playing tricks on you. You have to overcome that. That's what learning is. That's like the definition of learning. Let's start with aluminum, okay? What is the charge of aluminum way over here on the left? You can say positive, you can say negative, you can say neutral. It is neutral. What is the charge of aluminum over on the product side? In order for it to go from neutral to positive, did it gain electrons or did it lose electrons? Okay, this is where I was afraid, and most of you said the correct thing. But what I'm afraid of is that when you see that positive 3 symbol, you're going to think that it means it gained 3. When you see that positive 3 symbol, that means that there are 3 more protons. Well, how did it get that way? 3 electrons were lost. This lost 3 electrons, okay? So did aluminum, here's your choices. Did aluminum get oxidized? Did it get reduced? Or did it experience no change? Aluminum was oxidized. So it went from being neutral to a positive 3 ion by losing 3 electrons. This is oxidation. No, it's just it's an ion. Okay, the next one, let's take a look at iron. Jade, what is the charge of, what is the status, I should say, of iron on the reactant side? Your choices are positive, negative, or neutral. Okay, positive 3. So this is positive. Jade, what does this mean? How does it have a positive 3 charge? How's that happening? It has 3 more protons than it does electrons. And Jade, on the product side, what is the status of iron over there? How did that happen? How did it go from a positive 3 charge to neutral? It gained 3 electrons. So when we say that we're gaining something, Jade, is that something that's being gained going to be on the reactant side or on the product side? If it's being gained. No, that's not my question. I said, is it going to be on the reactant side or on the product side? So when Plant High School has seniors walk out of Plant High School, they're being gained. If something is being gained in a chemical reaction, do you write it on the left side of the reaction or on the right side of the reaction? Is that the reactant side or the product side? Correct. So you said that iron, I don't want to put words in your mouth, you tell me if I'm wrong. Did iron gain 3 electrons to be neutral or did it lose 3? What happened? So it lost 3 electrons to be neutral? We're getting all confused now. We're going the wrong direction. It went from here to here. What happened? That's why I wanted to hear. It gained 3 electrons. My next question is, because it gained 3 electrons, are those 3 electrons going to be on the reactant side or on the product side? That's what I was hoping to hear. Glad we got that straightened out. Okay, so we have iron plus 3 electrons yields or excuse me, iron 3 yields neutral iron. Jade, it gained 3 electrons. Is this oxidation or reduction? That is correct. And then lastly, Kayla, what is the charge of the oxygen over here on the reactant side? Is it positive, negative, or neutral? Negative. All right. What is the charge of the oxygen on the product side? Did this oxygen experience a gain of electrons, a loss of electrons, or no change? That is entirely possible, guys. You could have oxygen, in this case, experience no change. So here we have oxygen with a -2 charge. It remains oxygen with a -2 charge. It experienced no change. That will happen. Okay? Okay. Perfect. So let's go over oxidation numbers. I told you that there's more than one way to identify them. I have 9 rules, okay? Determining oxidation numbers. Arshan, if you need to go, you better go fast. Okay, yesterday you guys learned that you can look up the oxidation number by looking at the periodic table. Sometimes it's not always that easy, but this is not going to be that bad. As I said, there's 9 different rules. It's really not that bad, okay? I think you'll get the hang of it. Tomorrow's going to be kind of a easy day, and you'll be able to apply these to that just to get some practice. So here's rule number 1. In determining the oxidation numbers. The oxidation number of an atom of any element is 0. So for example, sodium, 0. Oxygen, 0. Chlorine, 0. Thorium, 0. These are all neutral. How do I know they're neutral? There's no charge symbol to them. I do not see a plus or minus anywhere. So whenever you have an atom by itself is important. Its oxidation number is 0. That means it is not gaining electrons. It is not losing electrons. It is zip. Okay? Number 2. Hold on a sec. All right. The oxidation number of a monatomic ion is equal to the ion's charge. So if I have calcium with a +2 charge, its oxidation number is +2. If I have bromine with a -1 charge, its oxidation number is -1. When you have a monatomic ion, when I say monatomic, how many atoms make up that ion? 1. Its charge is what its oxidation number will be. All right, so after every 2, I'm just going to throw a few on the screen. You just tell me what they are, okay? After every 2, I'll do a few examples. We'll go one person from each row. Emma, what is the oxidation number of that? 0. Nick, what is the oxidation number of that?
3.
Yeah, say +3. Colby, what is the oxidation number of that?
-2.
Kendall, what is the oxidation number of that? You're not following. Rule number 1.
Oh, 0.
0. Max, what is the oxidation number of that?
+5.
Jade, what is the oxidation number of that? Correct. Okay, good. Let's go to number 3. The oxidation number of the more electronegative atom in a molecule is the same as the charge it would have if it were an ion. The oxidation number of the more electronegative atom in a molecule is the same as the charge it would have if it were an ion. So let's take a look at the few examples I have here. We have NH3. I want to know what the oxidation number is of the nitrogen there. What is more electronegative when you're looking at NH3? Nitrogen or hydrogen? Nitrogen is closer to fluorine on the periodic table. And so what you will determine is that because nitrogen is more electronegative, its oxidation number is whatever its charge would be. So based on nitrogen's location on the periodic table, what would its charge be? -3. That means that is what its oxidation number would be. If I have nitrogen monoxide, what element is more electronegative, nitrogen or oxygen? Oxygen is more electronegative, and because it is more electronegative, what will its oxidation number be? -2, because that is what its charge would be on the periodic table. Number 4. This one's easy. The oxidation number of fluorine is always -1. No exceptions. So if I have LiF, what is the oxidation number of fluorine? So what must the oxidation number of lithium be? Right. Okay, let me think of a few I could come up with for this. I think we need some practice with number 3. Number 4 is easy. I mean, it's always -1. Yes, Arshan.
What about, doesn't that conflict with the first rule?
Is fluorine by itself?
So it's -1 if it's something else.
Mm-hmm. Okay, let's do some practice with number 3. Second person each row. Here we go. What is more electronegative, John? Selenium or oxygen? Okay, so what is the oxidation number of oxygen? No. Rule number 3, John. The oxidation number of the more electronegative atom in a molecule would be what its charge would be. So what would the charge of oxygen be? You have a periodic table on your desk. Everybody does. Somebody took it then. What? Yes, -2. Okay, let's go to the next one. I got to think of these. I make these up. Okay. That's easy. What's more electronegative, carbon or chlorine?
Chlorine,
So what is its oxidation number?
-1.
Correct. Next. OF, oxygen fluoride. What's more electronegative? So what is its oxidation number? Right. Derek. Let's see the last one we have. S2P8. I just made that up. What's more electronegative, sulfur or phosphorus?
Sulfur,
So what is the oxidation number of sulfur?
-2.
Got it. All right, good. Rule number 5. The oxidation number of oxygen is always -2 unless it's bonded to fluorine. In the event that it's bonded to fluorine, it's positive. It's always going to be -2. However, if it is ever bonded to fluorine, it's going to be a positive. What's that? No, just positive. It depends how many fluorines there are. Okay, 5 down, 4 to go. All right, this one's easy. The oxidation number of hydrogen is +1. There's one exception, unless it's bonded to a metal, then it is -1. So for example, you have sodium hydride. Sodium is a metal. So sodium would be +1, hydrogen would be -1. But 9 times out of 10, 99 out of 100 actually, when you guys deal with hydrogen, it'll be +1. There might be that one situation every now and then where it is bonded to a metal, and so it would have to be -1. Number 6 is going to be associated with rule number 7. Yes?
If it's bonded to like oxygen, or not, like, if it's bonded to like one of the ions, then why would that be like positive one? So because then would it take more like negative ions?
If it's, yeah, but it's going to depend on how many hydrogens there are. If it's like H5, O, whatever, let me think of one. Let's do H2O. Oxygen is more electronegative, so it's going to be -2.
Right.
And that means that hydrogen would have to be +1. +1 plus +1 is going to be +2. That balances out the oxygen -2. I'm not sure what you're getting at.
I thought okay.
Remember, these are oxidation numbers, not charges.
Well, just because like earlier you said to find the oxidation number of the molecule, then you find the more electronegative element.
Right? So let's look back at that. Hydrogen is one of the least electronegative elements, and it's also in group 1, which is going to say you look at it's going to be +1. it's seldom going to be taking electrons from anything else. That's why it's going to be losing electrons, hence its oxidation number, +1. I can't, the only reason why it would be losing, or excuse me, gaining electrons is based on rule number 7. And we're not done yet. We still have some rules to go. Rule number 6 and rule number 7 are tied into each other. Rule number 7 is the elements in group 1 are +1. The elements in group 2 are +2. Aluminum is +3. So for an example, you have potassium is +1. Calcium is +2. And aluminum is +3. The only reason why hydrogen would have a negative charge is if it is bonded with a, or I shouldn't say charge, excuse me. The only reason why hydrogen would have a negative oxidation number is if it is bonded to another metal, like anything group 1, group 2, or the D block, or even aluminum. Yes, Derek, if you need to. Okay, number 8, we have 2 more rules. The sum of oxidation numbers in a neutral compound is 0. So when you hear sum, what type of math will you be doing? Addition. The example I want to use here is calcium bromide. Just by looking at how I wrote calcium bromide, does it have a charge or is it neutral? This is so important. And year after year, when I teach this class, the majority of the class is quiet when I ask that question, and it just happened here. How can you tell that this compound is neutral, Max? Do you see? Your eyes work. Do you see a positive or negative symbol anywhere near that calcium bromide? No. It is so simple. If you don't see a positive symbol, and if you don't see a negative symbol, the charge is neutral. There is no charge. It's 0. Are we clear on that? I try to say every year, all you have to do is look. Don't freak yourself out. If there's no charge, if you're looking in this neighborhood right here, and there's no charge in the highlighted area, it's neutral. That means that the charge of the calcium and the charge of the bromine have canceled each other out. So knowing that, calcium is found in group 2. So what is its oxidation number? +2. Bromide is found in group 17. So what is its oxidation number? -1. How many bromides are there? 2. So what is +2 plus -1 times 2? 0. The answer is 0. How about this? This is going to be rule number 5. What is the oxidation number of oxygen? -2. How many oxygens are there here? 3. What is -2 times 3? -6. How many irons are here? What must the oxidation number of the irons be in order for it to equal +6 to balance out the oxygen's -6? You gotta say positive. +3. What is +6 plus -6? 0. If you do not see a charge, it is neutral. Okay, Max? And here's the last one, number 9. The sum of the oxidation numbers of the atoms in a polyatomic ion, here we go, is equal to the charge of the ion. Okay. Max, does this have a charge? Yes, it is. What is its charge? So here's what you guys need to look at. I'll let you finish writing, then I'll talk about it, then we'll be finished for today. We're not done yet, though. I want to talk about this one. What this is saying is that the oxidation of sulfur in the oxidation number of oxygen must equal -2. That is what you must figure out. So let's do that. And then we'll call it a day, and then we'll do an in-class activity tomorrow. Okay. Rule number 5. What is the oxidation number of oxygen going to be? -2. How many oxygens are there here? 3. What is -2 times 3? -6. Sulfur, we don't know yet, but what must the sum of both of these numbers equal? -2. So what must the oxidation number of sulfur be in order for the entire sum to be -2? Must be +4. +4 plus -6 equals -2. Let's do one more. Phosphate. Does this have a charge? Yes, it is -3. What is the oxidation number of oxygen? -2. How many oxygens are there? What is -2 times 4? -8. What must the sum of both of these numbers be? -3. So what plus -8 equals -3? Phosphorus is going to be +5. Tomorrow I'm going to give you guys an assignment where you're really going to practice these skills. So by the end of tomorrow's class, you'll be experts at it. You do not have homework tonight, though.